Welcome to a SimCenter AimSim Student Edition tutorial discussing how to perform experiments. Experiments are saved iterations of a system. They each reference different sets of parameters for a system and can also include the respective simulation results. For this simulation, we begin with the model of a simple electric motor with a constant voltage supplied of 10 volts, following a torque command to increase from 0 to 50 Newton meters in 10 seconds. The thermal behavior of the motor's housing is reflected with an aluminum thermal mass weighing 1 kilogram and experiencing convection with the surrounding air. The motor is driving a shaft that has a moment of inertia of 10 kilograms meters squared without friction. One simulation has been performed on the model, with results available for current drawn by the motor, as well as the shaft speed. To begin, the experiment menu can be made available through the Edit, Show/Hide menu and can be displayed in both parameter and simulation mode. Once available, there are three different options to select from, to the top left of the window. The first is to create a linked experiment, which creates and saves an experiment in a user-specified folder. When selected, a file browser window appears for the user to save the model in the desired location. If moving the model's .ame file from its current location on your computer, the link between it and the experiment file could be broken. The next is to create an embedded experiment where the saved files are stored within the model's .ame file. This allows for the experiments to be shared with the model as one file. Both of these options can be selected as well directly from the Run monitor after the simulation is complete. Both of these choices save the model's parameters as well as any simulation results to the experiment. The third option is to create a parameter-only experiment, which by its name only saves the model's parameters, but not the simulation results. For this demonstration, we will use embedded experiments. When selected, a new item will appear in the experiments dialog box. The user can then assign a new name and description for the experiment. The model with the current parameters and the simulation results available within it will be saved into this experiment. Now let's adjust the model to increase the torque command to 100 kilograms meters squared and include some friction on the inertial load of 10 newtons per RPM and perform another simulation. Once complete, new results are available for analysis for the current drawn by the motor and the shaft speed. This model iteration can be saved as another experiment by selecting the same embedded experiment icon with its own title and description. Moving back to the first experiment can be done by double-clicking on it in the experiment window. A message will appear to confirm the parameter changes between the experiments, with selecting Yes confirming the transition. The original simulation results are available once again, with the original parameters in place. The remaining three options within the experiment window include a delete option to remove an highlighted experiment. If deleting a linked experiment, the file saved locally will still be available on your machine, just not present in the current model. The next option allows for parameter comparison. When selected, a dialog box is displayed that asks the user to select a reference and analyzed experiment to compare the differences in parameters. Selecting experiment 1 for the reference and experiment 2 for the analyzed will show the differences between the two after selecting the Run button. In the window, each component with differing parameters will be displayed, and when opening the dropdown for them, the values for the reference and analyzed parameters of the experiments are displayed. The last option is to apply parameters of a selected experiment onto the open model. With experiment 1 open, select experiment 2 from the window and select this option. After confirming, the new torque command and friction on the shaft are present within it. A simulation will still need to be run after doing this to analyze the new results with these parameters. When applying parameters, the model saved for experiment 1 is not overwritten and can be reopened to reset its parameters and simulation results. And with that covers the basic operations within the experiments feature, showing how experiments are an excellent way to quickly work within and compare varying parameters across multiple components of a model to determine their effects on the system. For further information, the help documentation on experiments can be easily accessed within the window. Thank you for watching.